Hello students, welcome to my session. Myself Svanaja, lecturer in physics from Government Polytechnic, Nirmal. So today I am going to explain the electronics. So in this session I will explain the band theory of solids, the, the valence and conduction band, the forbidden gap between the valence and conduction band. I'm going to explain the classification of the matter on the basis of the energy band diagrams, and finally the Fermi level. So first of all, we know that the matter available in three different states like solid state, liquid state and gaseous state. The matter sometimes present in three states at different conditions. For example, water available in a liquid form, solid form or gaseous form. So here I'm going to discuss the solids in this chapter, the concept of band theory of solids. So first of all, what is meant by the solid? Solid is the matter in which atoms are arranged in systematic space lattice. So here the matter in which atoms are arranged in a systematic space lattice, packed and have a definite shape, size and exhibit large attractive force on among the atoms is called solid. So in the matter, the atoms are arranged in a systematic space lattice and they are closely packed and have a definite shape. The solid have a fixed shape and size. And among them for atoms, the atoms exhibit very large amount of attractive forces among the atoms. So this matter is called solid. So we are in daily life we are observing so many solid matter like stone, means the brick, the wooden block or iron, or any metal coin, any metals, rods. So these are all the solids. So in this, atoms are arranged in a systematic space lattice and they are closely packed, having a definite shape, means the fixed shape and size, and exhibiting the large attractive forces among the atoms. Atoms are called the solid. So you can see in this figure the atoms are arranged in a very systematic space lattice. It is a intermolecular structure of the solid, you can see in this slide. Then we go for the band theory of solids. In any crystal, each electron has a unique position, and each electron means no two electrons see exactly in the same pattern of surrounding charges. Means we know that according to Pauli exclusion principle, no two electrons have the all quantum numbers same, means no two electrons have the same energy. So every electron has a unique position and each electron will have a different energy level. So we have in atoms there are so many electrons will be present in the atoms. So each electron has a definite energy level in the crystal, or means in the solid. And these energy levels are very continuous, means there are so many electrons present in the atom and each electron have the definite energy level, and these energy levels are continuous, and with continuous energy variations they are existing in the atom. So all the energy levels, the continuous energy levels will form the energy band. The continuous energy level with slight energy variation will form the energy band. So here in the band theory, so you can see in the isolated atoms, observe the slide here, there are energy levels 1, 2, 3, 4, 5, means the energy levels, so means the set of energy levels is a band. The set of energy levels is a band. So, and the orbital, so he observed the slide. In isolated atoms, the electrons are arranged in energy levels. So, nucleus contains positively charged protons and neutrally charged neutrons, means the orbital electrons negatively charged and revolving around the nucleus having a specific energy levels, and these continuous energy levels are said to be energy band. So, in this way, the energy bands will be formed in the atom. Now, what are the different types of the energy bands are present in the atom? So, here there are two basic energy bands in the solid. They are valence band, conduction band. And there is one more energy band existing between these two, valence band and conduction band. First of all, how these bands are formed, the continuous energy levels forming energy bands. Now, due to intermixing of neighboring electron, the energy levels, the permissible energy level increases. Due to intermixing of neighboring electron, the energy levels, the permissible energy levels increases. The splitting are closely spaced, means they form a virtual continuous and called energy band. So there are neighboring energy electrons, means they are forming the energy level due to intermixing of neighboring energy levels, electron energy levels. And here, first of all, the valence band. The electrons of the atoms rotate around the nucleus in certain permitted energy levels, and electrons near to nuclei are strongly bonded, whereas the electron in the outermost orbit will be not strongly bounded to the nuclei. We know that. So, the electrons are moving around the nucleus, and the electrons the near to the nucleus are tightly bound to the nucleus, whereas the electron in the outermost orbits are not strongly bounded to the nuclei. And the electrons in the outermost orbit are called valency electrons. We know that the electrons existing in the outermost orbit are called the valency electrons. Now, the band of energy formed by the series of energy levels containing valence electrons. The band of energy formed by the series of energy levels containing valence electrons is called valence band. Now, in this band, the valence electrons are filled and having highest occupied band energy. The valence electrons are filled and having highest occupied band energy. Now, the valence band may partially or completely filled at any temperature. Filled at any temperature depending on the nature of the material. So, this valency band will be either partially filled or completely filled depending on the nature of the material. So, this is the valence band. I am repeating once again. Here the electrons which are existing at the outermost orbit are called valence electrons, and these are not strongly bound to the nucleus. Now, the band formed by the continuous series of energy level containing these valency electrons are called valence band, and it will be half filled or means partially or completely filled up depending on the nature of the material. So see here in the slide, there is a valence band and above that there is a conduction band. So this is the valence band. Next we go for the conduction band. In the crystal, there is a continuous variation of energy levels. Means after valence band, there will be continuous variation of the energy levels. The next energy level of the energy band is called conduction band. Means the permitted energy band next higher to the valence band is called conduction band. And the excited electrons from the valence band can easily move into the conduction band, whereas it is generally empty. So the conduction band is generally empty band, but the excited electrons from the valence band can easily move to the conduction band. Means in the conduction band, the electrons or excited electrons will be move into the conduction band, and the occupied electrons are called conduction electrons. The excited electrons moving into the conduction band are called as conduction electron. Means due to these electrons only the conduction takes place. And this conduction band is lowest unfilled energy band. Means it may be empty or partially filled. It is the lowest unfilled energy band, whereas the valence band is the highest occupied band energy. Now there is one more band which is formed by the series of energy levels above the valence band and below the conduction band. Am I clear? The band which is formed by the series of energy levels above the valence band and below the conduction band is called forbidden band. Means in between the conduction band and valence band there is a region of energy gap known as forbidden band or band gap, which is formed by series of closed levels above the top level of valence band and below the bottom of conduction band. The forbidden band is free from electrons. Means electron can't exist in this band. There is no electron present in this band. Means it is free from electron. When the electron in the valence band absorbs sufficient energy, it jumps into the conduction band just by crossing the forbidden gap. The excited electron from the valence band absorbs sufficient energy and go into the conduction band just by crossing this band gap. So this is called energy gap, and its value may large or small, and sometimes it is completely zero depending on the material, depending on the nature of the material. Either it will be large means or small, or sometimes it is zero depending on the nature of the material. So see in the slide, the three gaps, the band gaps means energy bands are shown in the figure. First of all, the valence band means it is filled, either partially or completely filled energy band, and above that there is a forbidden gap, means above that the conduction band, means the forbidden gap is existing between the conduction band and valence band. Now you can see the blue color dots here in the valence band. These expressed electrons expressed in this dots here, and the electrons are excited. One electron is excited to conduction band just by crossing the forbidden gap, means there is a gap. One electron excited to the conduction band means there is a gap in the valence band. The gap means the absence of that electron is called as hole. So the concept of hole will be discussed in the next session. Just I'm explaining what is the hole in the valence band. This hole is nothing but the absence of electron is called as the hole, and its concept of the hole will be discussed in the next session. Means we'll go for the type p-n diode, types of p-type semiconductor, n-type semiconductor. You can get the knowledge about the whole concept. Now we go for the next topic, that is the classification of the matter on the basis of the energy band diagram. So now a useful way to visualize the difference between the conductors, insulators and semiconductors is just to plot the available energies for electrons in the materials. Means instead of having discrete energies, as in the case of free atoms, the available energy state forms the bands. Instead of having discrete energies, so in case of the free atoms there will be discrete energies, but the available energy state forms the bands, and the band gap is different for different materials. So and there is a classification depending on this band gap, forbidden band gap. Now what is the classification? Let us see. First of all, the insulators. So we know that in case of insulators the conduction is very less compared to conductors, and in case of insulators the forbidden gap, the forbidden energy band gap is wide, means very large. There are no electrons in the conduction band. There are completely no electrons in the conduction band, means it is completely unfilled. Conduction band is completely empty. So due to these electrons cannot jump from the valence band to conduction band, means the valence electrons are bound very tightly to their parent atoms. The valence electrons very tightly bound to the nucleus. Now in the presence of very high electric field, first of all the valence electrons are tightly bound, but due to some external large electric field the electrons can move from valence band to conduction band. And if the large amount of energy is applied, some electrons may jump into the conduction band just by crossing the forbidden gap. Now how to give this energy, external energy, means just by increasing the temperature of the atoms. Means by increasing the temperature, the electrons may go into the conduction band and they become conductivity process. So they go into the conduction band, and due to the conduction electrons, the conductivity takes place. Means at very high temperatures they become conductors at very high temperatures. So you can see the forbidden energy gap between the conduction band and valence band. It is very large compared to conductors and semiconductors. So in the insulators, the resistivity is in the order of 10 power 7 ohm meter, and the gap, energy gap, is more than 3 electron volts, and up to it will be 10 electron volts for a glass like material. So it is above 3 electron volts, and it will be equal to approximately 10 electron volts for glass material. So it is insulators means there is no conductivity, but as the temperature increases, some electrons may actually, the electrons, valence electrons, are tightly bound to the nucleus, but by increasing the temperature, some energy will be acquired by these tightly bound valence electrons, and they may cross the forbidden gap and may go to the conduction band and acquire some conductivity. So at very high temperatures only the inductors are acts like an conductors. Means at 0 temperature or at 0 Kelvin there is no conductivity, means there is no external energy for the atoms. And what are the examples for these insulators? The rubber, plastic, glass, mica and quartz. These are the examples for insulators. Now we go for the next classification, conductors. The conductor is a material that easily conducts electric current. Conductor is a material which conducts electric current, and there is no forbidden band. There is no forbidden gap. Means the valence band and conduction bands completely overlap each other, and there are plenty of free electrons are available and easily enter into the conduction band. So in the conductors, means the valence band and conduction band overlap each other, and the valence band is partially empty, and the electrons from the lower level can move to the higher level by making the conduction possible. Hence, the resistance of such material is very low and the conductivity is very high. And due to absence of forbidden band in the conductors, there is no structure to establish holes. As we know that what is hole? The absence of electrons. Means in the conductors, due to absence of forbidden gap, there is no structure to establish holes in the conductors. Means the total current in the conductors is simply due to the flow of electrons. It is due to flow of electrons only. Now, the most of the metals we know that they are good conductors. And what are the examples for these conductors? Copper, silver, gold and aluminium. These are the some of the examples of the conductors. So see the slide. So the energy band diagram, the valence band and conduction band completely overlapped. Means there is no gap, energy band gap between the conduction band and valence band. Finally, the semiconductors. Semiconductors, the forbidden band gap is very small and it is approximately less than 3 electron volts. Whereas for electrons it is above the 3 electron volts and for semiconductor it is below 3 electron volts. Because of this small band gap, even at room temperature, some electrons may acquire sufficient energy to cross the forbidden gap and enter into the conduction band. So these electrons, even though small in numbers, can move into the conduction band. Means at 0, even at 0 Kelvin, actually at 0 Kelvin, there are no electrons in the conduction band and the valence band is completely filled and it acts like an insulator. But as the temperature increases, the conductivity increases. The forbidden band gap decreases. As the temperature increases, the forbidden band gap decreases and some electrons liberated into the conduction band. And with such an small energy gap, the presence of small percentage of doping material can increase the conductivity dramatically. Means at 0 Kelvin it acts like an insulator, but by increasing the temperature the forbidden band gap will be decreases and some conductivity takes place. And there is one more method to increase the conductivity in case of semiconductor, that is the process is called doping. Means we are adding some impurities to the pure form of the semiconductors to increase the conductivity of the materials. And this forbidden band gap is equal to 0.7 electron volts for germanium and it is 1.1 electron volts for silicon. Means the band gap is lies generally between 0.1 to 1 electron volt. And the resistance of semiconductors lies between the value, the insulators and conductors. The resistance is in between intermediate stage of the insulators and the conductors. So see the slide. The valence band and conduction bands are situated and there is very small forbidden energy band gap between valence band and conduction band. This is the semiconductors. Now we go for Fermi level. What is meant by the Fermi level? The Fermi level is a term which will be used to describe the top of the collection of electron energy levels at absolute zero temperature. To describe the top of the collection of energy levels of electron, means the top of the collection of energy levels of electron, nothing but the highest energy level. The highest energy level that an electron can occupy at absolute zero temperature is called Fermi level. It is the highest occupied energy level at absolute zero temperature. Now consider that the electric potential energy of the conduction electron is, suppose it is U, and the mechanical energy is E, and E is equal to 0, corresponds to partially filled energy level. And the highest occupied energy level in this band at absolute zero is called Fermi level, and the energy corresponds to this level is called Fermi energy. Fermi energy. So observe the slide here. The distance is situated and energy along the y-axis. The electrons, there are so many energy levels are situated, and the electrons are filled up to certain level only, and above that they are completely empty. So highest possible energy level, highest energy level that can be electron occupied at 0 Kelvin, so that will be called as Fermi level, and the energy corresponds to this energy level is called Fermi energy, and it will be equal to 7 electron volts for copper. And this Fermi energy level lies between valence band and conduction band, and it is the position of Fermi level is different for different materials depending on the nature of the material. Means highest occupied energy level by the electron is different, means the behavior of the electron. We have to consider the situation, means the holes, number of concentration of electrons, holes, and the internal structure, the band energy, means the energy band positions, valence band, conduction band positions. All these factors influence the position of the Fermi level in the crystals or in the solids, and it is different for different materials. It is the highest occupied energy level by the electron. So at 0 Kelvin, lower energy level of conduction band are occupied by the electrons, while upper level is unoccupied. At 0 Kelvin, only lower level of conduction band is only occupied, whereas upper levels are unoccupied. So this is the Fermi function, and energy will be plotted in the second graph. At 0 Kelvin, only lower energy levels of conduction band only occupied by the electrons. Now, so we discuss in the session the band gaps, the classification of conductors, insulators, and semiconductors in this session. So here the conductors, there are electrons are situated here. The red color box, that is the valence band, the blue color box here you can see, that is the conduction band, means there are completely overlapping between the valence and conduction band in case of conductors. And in case of semiconductors, it is a very narrow energy gap, 1 electron volt existing between valence and conduction band. And in the insulator, very large wide energy band gap, it is order of 5 electron volts in case of insulators. You can clearly picturized in this figure the position of valence band and conduction band clearly mentioning in this diagram. So clear visualization of conductors, insulators and semiconductors. So this is the band gap energy diagram on the basis of forbidden band gap. So in this session we'll discussed the solid. What is meant by the solid? So it is nothing but the atoms systematically arranged, closely packed, having fixed shape, size and exhibiting large attractive forces is called the solid. And in the solids the electrons, each electron have a fixed energy level, and fixed energy levels are continuous, means the continuous energy levels formed as energy bands. The energy bands, we know that the electrons which existing near the nucleus, near to the nucleus, are tightly bound to the nucleus, and whereas the outermost electrons are not tightly bound to the nucleus, not strongly bound to the nucleus. So the electrons in the outermost electrons are called valence electrons, and means as we give the some of very small amount of energy is given to that outermost electrons, they can be free from the atoms. They are free electrons. For giving small amount of energy levels, they can be free. So as the energy levels, means the band formed by the continuous energy levels having these valence electrons are called the valence band, means the valence band consists of valency electrons. By giving some energy to the valence electrons, they can easily liberated into the conduction band. So the valence band will be either completely filled or partially filled by the electrons depending on the nature of the material. Whereas the conduction band, it is permitted energy level which is next higher energy level of valence band. Means the conduction band consists of conduction electrons. What is meant by the conduction electrons? When the electrons from the valence band, if they are liberated into the conduction band, and they are the reason for the conductivity, means valence electrons are liberated, means they are free from the atoms, they are free from the nucleus. These free electrons will move to the conduction band and they constitute some conductivity. So that electrons, the liberated electrons will move to the conduction band, and the electrons in the conduction band are called conduction electrons. Generally the conduction band is empty. During the conductivity process only it will be filled, means it is lowest unfilled energy band. Either it is empty or partially filled by the electrons. Next, there is one more energy band gap, that is forbidden energy band. In between the conduction band and the valence band, there is a region between these two called as forbidden band, and it is above the top level of valence band and below the bottom of the conduction band, and it is free from the electrons, means there is no electron will exist in the forbidden band. Just the electrons liberated from the valence band by acquiring some sufficient energy and liberated to the conduction band only by crossing this forbidden band gap. If the electrons having the energy to cross the forbidden band gap only move to the conduction band. If there is no sufficient energy to cross the forbidden band gap, they will not go to the conduction band. They just stay in the valence band only. Only by giving the energy to cross the forbidden band will move to the conduction band. And based on the width of the band gap or forbidden energy band, there is a classification, that is conduction band, valence band. Means there is a classification: conductors, insulators and semiconductors. In insulators, forbidden band gap is very large and there is no electron in the conduction band. Means there is no conductivity under normal conditions or at the room temperature or at 0 Kelvin. But if we give sufficient energy to the valence electrons, means why? Because valence electrons are tightly bound to the nucleus in these insulators. Only by giving some energy to the valence electrons, they are free from the nucleus and then move to the conduction band. How to give this energy? Means only by increasing the temperature. By giving the temperature, some of the electrons will acquire the energy and go to the conduction band by crossing the forbidden energy gap. Whereas in the energy band gap is also very large. Means it is above the 3 electron volts or up to 10 electron volts. Means at very high temperatures only the electrons can liberated into the conduction band. Means they can cross the band gap. If it is not sufficient energy, means if it is 2 electron volts or it is 1 electron volts of energy, it is not sufficient to cross the forbidden band gap. That is, it is order of 3 to 10 electron volts between the valence and conduction band. So at very high temperatures only the conductivity takes place in the insulators. Whereas at 0 Kelvin or at the room temperature, it completely conductivity is equal to 0. And in the conductors, it conducts electricity easily. Means there is no forbidden band gap between valence band and conduction band. Completely overlapped each other, and the electrons which are existing in the valence band can easily move to they are existing in the conduction band only. Means there is no band gap. Means plenty of electrons or very large amount of electrons will be available for the conductivity here. Means even at 0 Kelvin or even at room temperature itself, there is a very large conductivity in case of conductors, and there are some copper, aluminium, gold, silver. These are the best conductors. Means even at 0 Kelvin the conductivity takes place. And in case of semiconductors, the forbidden band gap is not too small as means there is no band gap is not equal to 0 as conductors, or there is no large amount of forbidden gap as insulators. It is in between these two. The band gap value existing between the insulators and in conductors. So it is below 3 electron volts. Generally it is below 3 electron volts. And some electrons, even at room temperature, some electrons will move to the conduction band and some conductivity takes place at room temperature. But as at 0 Kelvin, the conductivity is completely 0. Means to increase the conductivity of the semiconductors, we have two methods. One is to increase the temperature of the material. Some electrons will easily liberated to the conduction band, or by doping concept we can increase the conductivity. What is meant by doping? Means by adding impurities to the semiconductors. Means by doping the material, the conductivity increases, and the resistance of the semiconductors also lies in between the insulators and conductors. The band gap as well as the resistance lies between the semiconductors and insulators. So it is in between, means the value is 0.1 to 1 electron volt. And for germanium it is 0.7 electron volts, and for silicon it is 1.1 electron volt. And the finally Fermi level is the highest occupied energy level that can be occupied by the electron at absolute zero temperature.